Why Tesla is designing chips. Tesla is the latest corporation to seek a competitive advantage in artificial intelligence by developing its own silicon chip manufacturing capabilities. Tesla released details of a unique artificial intelligence processor named D1 during a promotional event last month, which will be used to train the machine learning algorithm that will be used to power the company's Autopilot self-driving system. The event was centered on Tesla's artificial intelligence efforts, and it featured a dancing person dressed as a humanoid robot that the company plans to build. More information can be found by watching this video to the finish. Tesla is the most recent unconventional chipmaker to develop its own silicon from the ground up. As artificial intelligence, AI, grows more critical and more expensive to implement, other firms that have made significant investments in the technology, such as Google, Amazon, and Microsoft, are increasingly designing their own processors. Elon Musk, the CEO of Tesla, stated during the event that extracting greater performance from the computer system used to train the company's neural network will be critical to advances in the field of autonomous driving. According to him, if it takes a couple of days for a model to train, as opposed to a couple of hours, that's a major difference. Tesla has already begun designing circuits to interpret sensor information in its vehicles, after the company's decision to stop utilizing NVIDIA technology in 2019. However, developing the kind of powerful and complicated semiconductor required to train artificial intelligence algorithms is significantly more expensive and difficult. As Chris Gerdes, director of the Center for Automotive Research at Stanford University, who was in attendance at the Tesla event, put it, if you believe that the solution to autonomous driving is training a large neural network, then what followed was exactly the kind of vertically integrated strategy that you'd need. Tesla is relying more heavily on neural networks to recognize objects on the road than most other car makers, with a single massive neural network known as a transformer, getting information from 8 cameras at the same time. In August, Tesla's artificial intelligence leader, Andrej Karpathy, stated that the company was essentially constructing a synthetic animal from the ground up. The car can be looked at as a type of creature. In its own right, it walks around autonomously, observes its surroundings, and acts autonomously. Over the last few years, large-scale transformer models have made significant progress in domains such as language understanding. These advancements have resulted from the expansion of the model's size and data consumption. The greatest artificial intelligence programs require several $1 million worth of cloud computing capacity to train. According to David Cantor, a chip analyst with Real-World Technologies, Musk is betting that by speeding up the training, I will be able to make this whole machine, the self-driving program, accelerate ahead of the Cruises and the Waymos of the world, referring to 2 of Tesla's competitors in the autonomous driving market. Tesla's plan, according to Gerdes of Stanford, is based on the company's neural network. Tesla, in contrast to many other self-driving car firms, does not use LiDAR, a more expensive type of sensor that can view the world in 3 dimensions. Instead, it relies on the neural network algorithm to analyze the data from its cameras and radar, which it uses to interpret scene information. This is more computationally intensive due to the fact that the algorithm must reconstruct a map of its surrounds from the camera feeds, rather than relying on sensors that can record a picture of the environment in real time. Tesla, on the other hand, collects significantly more training data than other automobile manufacturers. Approximately 1 million Tesla vehicles on the road transmit video feeds from their 8 cameras back to the firm, which in turn sends them back to the company. For the huge transformer, Tesla says it employs 1,000 people to identify the images, noting the presence of automobiles, trucks, traffic signs, lane markings, and other features, in order to assist train it. Tesla also said at the August event that it will be able to automatically decide which photographs to prioritize in labeling in order to make the process more efficient. One concern associated with Tesla's method, according to Gerdes, is that beyond a certain point adding more data may not make the system any better. Is it simply a matter of gathering additional information, he wonders. In other words, do neural networks' capabilities reach a plateau at a lower level than you anticipate? The cost of answering the question is almost certain to be prohibitive. It has not only prompted some giant corporations to design their own processors, but it has also produced dozens of well-funded startups that are developing highly specialized silicon to support these large, expensive artificial intelligence models. The market for artificial intelligence training chips is now dominated by NVIDIA, which began by manufacturing processors for video games. When it became evident that its graphics processing units, GPUs, were more suited to running huge neural networks than the central processing units, CPUs, found at the heart of general-purpose computers, the business shifted its focus to providing artificial intelligence chips. In a clever reversal of causality, artificial intelligence is also pushing a diversification of semiconductor architectures. However, machine learning has been shown to be effective in automating portions of the chip design process, which is generally requiring extensive technical expertise and judgment. Google, Samsung, and other companies are developing chips that were created in part by artificial intelligence. Several technical questions remain about specialized chips like as Tesla's D1, according to Cantor, the analyst. These include how successfully they can be coupled together, and how well an algorithm can be broken up and dispersed across multiple processors. The author describes it as writing a hefty check to your software team, which they will be able to cash. Hui Peng, a professor at the University of Michigan who specializes in autonomous driving, believes that if the D1 proves to be a success, Musk may be able to sell it to other automakers, who would then be required to follow its technological lead. Peng admits that he has no idea whether the way Tesla is taking will be successful financially or technically, but he has learned not to bet against Musk in the past. It has done a lot of things that everyone believes aren't going to work, says the author. However, in the end, it happens. What do you think? Will Tesla D1 succeed? Let us know in the comments below. If you liked the videos, please subscribe and click on the bell icon for notifications on new videos. And as always, have a great day.